Alright, so once you guys have established a silhouette that you guys are going to proceed with, so I'm just going to do a really quick silhouette here for this demo. Okay, let's say this is the chosen silhouette. Some of you guys have silhouette structures that are a little bit more, it might be top heavy and it's kind of leaning, and it's, you know, in terms of physics it's probably not possible because a lot of you guys have, you know, this stuff going on. Don't worry that it might not make sense initially, but you'll try, you know, that's kind of the purpose of doing these exercises, because you want to explore just the very far-fetched ideas and the more conservative, practical ideas. So I want you guys to kind of get comfortable with the idea of just creating like cool proportions. But once you guys have chosen a direction, the next step is to break down the silhouettes into major shapes, like from very large, medium, and small shapes. So when I look at this, naturally I'm going to look into this shape here. So what I want to do is I just want to document that there's a square here, there's another square here, there's some kind of cylinder structure here, I have a leg piece here, and some kind of shape down here. Okay, this breakdown is a very basic shape breakdown. You know, it's just identifying your core shapes. So I have 1, 2, 3, 4, 5 shapes. So these are very rudimentary practices. But what I want you guys to do is try to figure out how many ways you can break down these major shapes. So for example, if I were to group these two shapes together, right? Maybe it's some kind of diamond or trapezoid kind of looking piece. Well, not trapezoid, but some kind of like obscure geometry with the leg extension here. So you have 1, 2, 3, 4 pieces. So I'm trying to just figure out how many ways I can break down this silhouette. Okay, because it's important that we identify the large, medium, and small shapes when we're starting to design the internal design for our silhouettes. Because right now it's all shape and proportion based, but we need to figure out, well, what are the details that are going to be contained inside, right? So I'm going to just do another quick one here. Okay, don't worry about these being too perfect. These are just to document them. Do you guys all understand what I'm doing here? Okay, very, very basic. The core idea is just to break them down so that when we design silhouettes based off of just pure outer exterior shapes, it's hard to determine what our interior shapes are going to be, because it's kind of up in the air, right? I mean, obviously when we're doing the silhouettes, we create some kind of internal information, but you kind of don't want to limit yourself with just that one idea. So I'm presenting 3 different alternative options or routes for us to further explore. Okay? So I want you guys to just do a simple breakdown, and from here, let's say we're going to go with, so I have A, B, and C, right? A representing this breakdown, B representing this breakdown, and C so on. Right? So if I have A that's representing this kind of breakdown where there's five shapes, so what I'm going to do is I'm going to create a ground plane, and with my marker I want to recreate these 5 shapes just very lightly. Just make sure it's quick. Don't spend too long on trying to capture, you know, the perfect proportion of this thing. If you want to add in the smaller shapes, you can too, but just keep in mind your 5 major shapes. Make this one a little bigger. So, based on your guys' research, I want you to kind of go back to some of the research pages you guys have done and start to implement some of the visual language into these these internal design studies. Okay, so for example, if I have something like, let's say I was inspired off of this camera, right? Obviously the video camera can't see the structure, but if I'm looking at the design language, or if I was inspired off of this tripod and the camera head, I'll start looking at just certain pieces and elements to translate into this breakdown. Okay, so obviously the silhouette is going to give us just the exterior shape, but what's in it in here we don't know, so I'm going to base it off of the details that are represented here. So let's say I have some kind of circular element. As far as the joints go, don't worry too much about representing all the joint areas. I just want you to keep in mind the separation of the pieces, because later on we're going to reinforce exactly how the joints are going to look and how they're going to be placed in these side view drawings. But for now, I just want you to dress up these sketches with internal details. Got my large shapes here. Got my other shape down here. Again, I'm gonna look at my reference. You can make things up, but then always refer back to your reference when you're stuck. Some kind of blast shield here. Okay, you don't have to spend too long on these. These should be, you know, they should go by pretty quick. Spend at most maybe 10, 15 minutes on each one. But I want you guys to just explore all these variations of, you know, internal shape designs, you know, and try to start to make sense of what is this massive shape here that's represented in my silhouette, and how does it look in linear information. Okay, so this is just a very simple breakdown of how we can start extracting our designs into something a bit more believable.
And we don't have to worry at this point functionally, like that's how it works.
Yeah. Don't worry about, well, John, I don't know how, you know, I can't fit in a hydraulic here or anything like that. Just think about, there's a circle here and there's a square here. What does that represent? Okay, here maybe there's a big square here, but I don't want to fill in that whole square. Maybe it's maybe what's up here are these huge barrels or something that fill up that silhouette. I don't know. It can be anything, really. It's up to you, but I want to fill up the proportion, but it doesn't have to be a solid shape, you know? Again, these joints right here are just representation of these shapes connecting, okay? Because like I said, there's 5 shapes in here, and they're being broken up one shape, another shape, and another shape here. And the way I'm connecting them is I'm just putting an indication of maybe there is something that connects it. Because right now, if they're just floating and it's just a gap, you know, it's not going to make as much sense structurally. It's just going to look like I just fudged the shapes together. But just doing a quick indication of, you know, maybe there's a pivot point here and this thing's connected up here, it will help to kind of unify and cohesively put together your shapes. Does that make sense? Is there anyone that did not understand what I just said? To me, in my brain, it might make sense, but what I'm verbally articulating might come out like mumbo jumbo. Yeah? You guys all understand what I'm doing here? I remember I was giving a lecture a couple semesters back, and I watch my recordings when I'm unsure of what I presented, and dude, one time I sounded like I was effing high, dude. I was like, what the hell am I saying? This is retarded, dude. So I apologize in advance if I kind of veer off, or if what I'm presenting sounds completely far-fetched. Okay, so just stop me in the middle of the lecture and just be like, can you reiterate on that? Or, you know, because I want to make sure that this is clear to you, not to just me or the recording. So I'm putting in these indication of detail. They look purposeful in terms of just a function of, you know, maybe this is some kind of lever wall thing that organizes these barrels or something. Please base your details, these obvious ones, based off of your primary function, okay? Just to kind of cohesively tie in your design together. Otherwise, I don't want them to be too far out from what you're trying to execute here. But things like that, it can be, try to tie it in. I mean, obviously for the demo, I don't have a solid design direction for you guys.
So when we're doing these, we're going to be doing based off our thumbnails.
Yep.
And they should have a function, a primary, secondary function.
Yeah, you should show off some kind of primary function. Okay, so if your mech has a drill or something, it should be represented in these drawings. Okay.
Because when we initially did our thumbnails, I obviously wasn't thinking function, I was just doing
Right.
the assignment. So if there isn't one, we just add one.
Well,
Give it one.
if you're not happy with the silhouette, I would redo your silhouette. If you do like a silhouette that you have, for example, I like this silhouette, but let's say for this silhouette, my primary function is it has to carry barrels and transport, and it has to also lift barrels. Okay, so it transports and it lifts barrels onto this this platform or structure back here. So if that's my primary and secondary function, in the silhouette it doesn't really say much because it's just a shape. But in these internal line drawings, I want to start representing what are these leg structures and what are these big pieces. Okay, so if this big square is a cockpit, try to represent, you know, a door or where the cockpit is, and if these are, you know, just some huge barrels, you know, represent that. But again, don't try to spend too long. I just want you guys to start thinking about your internal design. Because right now we have the shape that we like. We know the silhouette. So, do you guys all understand what I did here? Okay. Remember that this was based off of example A. Example A has a certain set of shape breakups. Okay? Example B has a different set of shape breakups. So if we look at example B, it has a larger shape here.
You're off screen.
Oops, thank you. It's a larger shape here, legs, pivot, and then some kind of shield thing. Okay, when I look at this, I'm thinking about how am I going to fill in this shape, right? So that's the first thing that's going to come to our mind. Well, maybe this is where the cockpit is located, and maybe it's just a large, cockpit, you know, for the user. So maybe, you know, the window or something is located up here. So I'm going to start filling that in, like, okay, here's a window shape. Maybe there's a segment that's open for this leg piece to fit in, right? Maybe the bottom here, other than it serving as a control station, maybe there's something else down here, like there's some kind of plug or outlet. So what it might do, to make sense of this, maybe it gets the these barrels and it's going to extract it by positioning it right underneath. Okay, maybe that's how I'm going to make sense of this large structure. Okay, so this is kind of up to you guys to explore your designs and not just say like, oh yeah, it's this one, just because, and you're not happy with it, you know. Like I want to explore like, well, what are the other possibilities of how I can come up with different design purposes within the same realm of our brief, but you know, uniquely different from one another. You know, and if your mech is industrial, please look at your reference for all the industrial machinery that you guys printed out, because there's a lot of great panel breakups. And details that your reference can provide. Maybe there's like an arm there that picks up. Does that make sense? Again, see, so when I did this design based off of this template B, I'm not as attracted to it as I am with these variations. So that's kind of the whole purpose, is to see like how many variants you can come up with within the same restraints. Okay, and so on. You know, I'm going to use template C, and I'm going to do a different design pass. So for this assignment, I want you guys to do a page for each. Okay, come up with 3 basic breakdowns. That's, you know, just like how it's represented here, like breakdown A, breakdown B, breakdown C, and then do a page for each. Okay?
Oh, so don't put them all on one page. Like
Yeah, don't put them all on one page. This is for the sake of the demo.
Based on one thumbnail.
Yeah, based on one thumbnail.
How many thumbnails?
I want you guys to just choose one thumbnail,
Okay.
because we are on week 2. Next week is we're going to get into 3/4 perspective drawing, and start drawing our mechs in perspective. So, say this mech is inspired off of like some organic paneling. Your paneling, this is inspired off like a leaf. I wouldn't literally draw leaves on there, but maybe the way you break up your panels, instead of it being like rigid, it's going to be more, it's going to have a lot more curvature. Okay? Even the legs, the way you do your legs, even structurally, when you design out the legs, it can be like really organic. It doesn't have to be like these stiff, you know, construction looking pieces. Because that's the thing, if you look at all these arms or these structures that are connected by hinges, they're really just kind of like it's almost like statues, or they're just kind of like these standalone pieces, right? And you can kind of mold them into any shapes because they're going to be connected in some way. So visually, you can actually manipulate them to look, you know, kind of in any way you want. And maybe the way it's formed this way is because it's actually going to collapse, and that's how it can actually go into some kind of compartmentalizing mode or something, right?
When you initially broke down your shapes in the first page, you broke them down to like 5, something like 5 shapes.
Yeah.
Is that just left up to us, however we want to break it down?
Yeah.
Number wise?
Yeah, I want to leave that up to you guys,
Cool.
because there is no right or wrong way
Right.
of how to break them down. But I do want to see a large, medium, and small shape. Please have those clearly represented. Otherwise, like I said when I was looking at your guys' silhouettes, there was a lot of small shapes composing a larger shape. And that's what's going to make your design very noisy and very unclear. Okay, good designs, they call, you know, successful designs very simple. It's because it's simple in the sense that when we look at it and analyze the shapes that compose a design, it's very easy to understand, and you can identify every area within the first minute of looking at it. So when you look at Apple products, it's literally a square with rounded edges, right? And within that square iPhone or iMac book, you're going to have another similar shape that's repeating that overall shape, right? and you're going to have little indications of those similar shape languages broken up into the rest of the product, right? But then there's, if you were to break that up into components, there's a large, medium, and small shape, right? So that's kind of the same principle that I'm using here, is what are my large, small, medium, small shapes here. Yeah, these, sometimes I look at these legs as a way of like sculpting a form. You know, sometimes the sculpture doesn't have to be a rigid rectangular piece, but it can also be very dynamic and organic, you know. Maybe there's a canopy up here. And there's all these barrels that are heat sensitive.
I just think it's cool when I see mechs that have fabric involved. Some sort of a piece of fabric.
Yeah, it definitely breaks up the material, because it's not always like metal, metal, metal. You know, it can be like metal, rubber, fabric, or something else, you know, glass, and things like that. It really helps just break up, you know, what you're looking at, and it doesn't become as static. Maybe in this one I have an open cockpit.
Would the difference between a mech and a robot be that the mechs are run by people and a robot would be? Can you just actually say that, or is it sort of an
I don't know. That's. I really don't know what the defining point is. I guess Mech is operated by a human being. All right, the next exercise. This isn't really pertain to the thumbnails or the silhouettes. This is to kind of get into the rhythm of drawing in perspective. So I want you guys to just do a few pages of complex box forms. Okay, I don't want you guys to do just, you know, regular boxes, but start looking at a box and try to mess with the form. Okay, messing meaning like manipulating, adding other shapes to bisect it or integrate it or, you know, merge together. So when I have this box, you know, I want to start getting used to the idea of presenting another shape that's possibly merged into it. You guys get that idea, that concept? So go crazy with this assignment. I want you guys to get used to combining these forms. Put in some round forms here. Okay, I want you to go in here and dissect and subtract you know, a square out of this piece. Give it chamfered edges.
What did you call those edges?
Chamfered?
Chamfer?
Yeah. Chamfered is, what I remember, I think they're like anything that's, I don't know, edged off or three angles, right? Is that the term for chamfer?
Yeah.
Okay.
Fillet is like a smooth, like a curve,
Yeah.
and chamfer is an angle.
Yeah, what Gurmuk said. He's an architect, so I trust him 150%. Also, I want you guys to do some cylinders as well. Do you guys all know how to draw a an ellipse in perspective. Okay, so what I do is I always draw a box, right, or a elongated rectangle or elongated box, and then I want to find my center point, so I draw an X through one of the faces and draw a vertical line and a horizontal line right here. And I want to make sure that my ellipse goes from one point to another. So it's going to follow this form. So I'm going to have that elliptical shape. Does that make sense? You guys all remember, you guys have done this at some point in your education, correct? Mm-hmm. Okay. So with that said, I want you guys to start doing get used to drawing cylinders and ellipses, bisecting into other shapes. Because again, if you think about our mech, we're going to have a lot of forms that have a lot of cylindrical structures, and you're going to have to get used to the idea of drawing ellipses. Okay, does that make sense? All right, let's do I want you guys to do about 5 pages of these. Okay, fill it up. All right, these should be pretty brainless. I mean, if you guys are struggling with perspective, then please talk to me after class. I'll give you just a simple breakdown of how to approach, a square in perspective. But as far as that, I don't want you guys to stress over this too much. It's just to kind of get into the rhythm of drawing structures and perspective, because when we get into our mechs, we're going to be doing a lot of ideations that are 3/4 view, and you're going to have to be able to just block these all out fairly fast, okay? Does that make sense? So we're building our confidence level up to that point. So next week, just keep in mind, I'm going to have you guys do 50 of these. We're going to start exploring our designs in 3/4 view. Okay, because I think we're all good for these 2D drawings. So let's start getting into these perspective boxes, and they call them like complex compound forms. So.
This is all the same process you use for your vehicles too?
Yeah.
It's all just the same thing,
Yep.
right?
Same exact practice. Even environments, if you think about it.
Yeah.
Because you're thinking about composition and what is that shape? How did it all coexist? In one space. So. If you guys have rounded forms, you can round off some edges here. If you want to duplicate that, I always go with the perspective guidelines here, and I try to recreate that same curvature. Does that make sense? So again, some of you guys might have mechs that have a curved front face, or a certain piece that has, it's not angular all the time. So just in case, let's try to explore some of these shapes so we're all kind of up to speed. Okay, cool. So 5 pages of those. Okay. So looking at my joint studies, I'm going to just take it one by one. I'm going to use the idea of the hinge joint. So the basic concept is one arm structure or two arm structures connected by a cylindrical joint, or a joint that's connecting these two pieces, right? And we've discussed this the first week. It's up to you on how these are connected, but that's just the basis of the idea. Now this is where we're going to start using them to kind of test our ability to see how we implement these joints into a design. Okay? So what I want you guys to do is, let's take the most generic looking bug. Alright? Let's say
Ladybug.
what?
Spider.
A spider. Let's say a spider. Or a baby baby bug.
I said
A baby spider. A ladybug. Alright, let's say a ladybug. Okay. I want you to draw a very geometric representation of a ladybug. So when I look at ladybugs, they have a hard round shell, some kind of a head, right? But for the head, let's just keep it basic. I'm going to keep everything geometric. It's my geometric representation of a ladybug. From what I remember, I think a ladybug has 6 legs, right?
Yeah, I think so.
Okay, has 6 legs, okay? So what I'm going to do is box this off. These don't have to be perfect. I want you to just focus on the gears. So if I'm going to use this gear, right, the hinge, the idea of this hinge, I want to see how I can take the idea of having a bug and replacing these organic legs with something of a hinge, right? So let's say if I have a hinge here, and this part of the hinge is connected to the body, and the legs come out like this. Have another hinge here. The legs do something like that. Does that make sense? You guys see kind of like why I'm using the purpose of this exercise is to kind of familiarize yourself of when and where to use this joint. Okay, try to keep it very basic for yourself. Don't, at first try to go really easy, simple, just so that the idea is really clear to you. And then once you feel confident, then you can go all hardcore and, try to come up with like multiple ways of utilizing this joint on one structure. Okay, so for example, the next one might be, let's say a crab. I don't even know what a crab looks like. I think in profile they have this kind of retarded football shape. And I think they have 8 legs. I believe they have 8 legs. Right? That's a crab, right? Oops, I'm off page. I'm going to draw a crab here. Let's try to keep them all in this perspective viewpoint. for this crab, I don't want to go crazy with this geometric form. So I'm going to simplify this thing and literally just put a box to represent the shape of the body. If you guys want to draw, you know, an organic form for the crab, that's fine. But again, my whole goal is just to kind of understand the basics of, you know, how do I create hinge points to represent, you know, how the arms fit into the body. That's my whole goal. Okay? So I'm going to just plot out. I think, you know, the arm's going to do something like this. Have another arm right here. Legs. I'm just kind of just plotting these out. I'm just guessing out where they land. And to plot out the other parts of the leg, what I'm going to do is just go in perspective. Draw out the heights here. And just mimic where the feet are going to land. Does that make sense? You guys all understand how I'm plotting out, you know, these in perspective? Am I going too fast? Is it getting too complex? Okay. So from here, I'm going to use that idea of that construction and just kind of now integrate my gear studies into here. So maybe for the arm, I have that hinge joint connected inside of the body. So I'm going to create an opening just for that hinge joint. Okay, and it's connected to this arm structure that's coming out. I have another hinge joint here that's connecting the small arm to my large claw. And the pincers also connected here. So there's going to be a lot of repetition of the same joint, but I'm just going to try to use it in you know, various studies. And same old here. In this one, maybe because there's two pincers, or just two tiny claws and they clamp together, maybe I have two joints that are independent of each other. This is where you can start. Getting used to the idea of utilizing this joint to create that kind of articulation. Does that make sense? Like how it's the same thing. I'm using the same language, the same gear language, and it's probably the most basic function, right? But I'm just placing it in different areas to kind of make up for, oh yeah, this is how that would work, or this is how that would work.
Is it okay to, once we incorporate the primitive shapes, to go over them, like stylize them? As long as we show the axis.
Yeah, you can stylize them.
Like speed forms almost, but not quite.
Speed forms?
Yeah,
On top
but
of these.
like, let's say that claw you design,
Yeah.
You can do that?
Yeah, right here? Yeah,
Or
yeah.
should you just do like an overlay of another paper and then.
Yeah, you can stylize them. I mean, the main important thing is I just want to see you utilize these connection points. But if you want to draw in a certain way or draw a certain type of shape, you can definitely, you know, definitely do that.
And you're only using one type of joint
Yep.
for each one.
So all this is created with that one hinge joint. Okay. And so on. Does that make sense? All right, let's do one page for each joint, and I want you guys to do 4 joints. Oh, sorry, 2 joints. So choose 2 basic joints, like a hinge and a ball joint. Do 1 page dedicated to a hinge joint. Do another page dedicated to a ball joint. Okay. Do another page with 2 combined joints. So we have a ball joint and a hinge joint. Okay. So I'm going to just quickly demo that page, so it makes more sense to you guys.
This is separate from the compound shapes.
Yeah, this is separate from the compound. So I have my hinge joint here. And let's say I have a rotating joint here. So I have a gear that basically bends in one direction, and I have one that's going to rotate. Okay. So what I'm going to do is I'm going to take these 2 base concepts and combine them together. And just like what you guys did with your custom gear shapes, use that, extrapolate that custom gear that you did and implement them into this next exercise. Okay. So again, I'm going to take basic animal shapes. Don't go too crazy and do a centipede or something. You know, you don't need to draw 40 legs, because you'll get the point after doing 1 or 2. But let's say I take like an ant or something. Okay, the ant has, or just a basic insect. Pincers. So it's an ant. Let me do my basic block out of that large. You see how this is large, medium, and small? You see how the dynamics also coexist in nature as well? So I want you also to keep that in mind. You know, when you're even doing these studies, you'll see, repeating elements when you're doing like insects as well. Okay, let's say I have this medium shape here. It's supposed to represent the head. So when you start doing these, and the way I'm doing them, even though they look really constructive and boring, I can turn this into a mech. I can say like, well, this is a cockpit, and there's a door here and whatnot. So just keep in mind that this exercise it might benefit what you guys are trying to achieve. So have some pincers here. Okay. Now, I have a hinge joint and a rotating joint. The rotating joint, I'm going to probably add in right here.
Is it, you want to see us? You want to see the draw through? You want to see that?
Yeah, I want to see you guys do a draw through. So, because a lot of these shapes are going to cover your hinges, but also, you know, this head. Not only can it rotate, but it can also turn. So here, I want to add in that hinge element. It has the ability to pivot and turn its head. Basic hinge joint for these pincers. Okay. For the legs, let's say I have a leg here, and a leg here. All right, I'm going to just plot them in perspective. Actually, don't even worry about the back leg. Let's just focus on the front for now.
You're a little bit off the page.
Oh shoot. Thanks. Are there any questions?
How many different joints could you combine together before it starts getting cluttered?
Well, you want to keep it, I would keep it like 2 max. Once you start doing 3, it becomes like this organic wiggly thing, you know? It's always, best rule of thumb is always combine 2 max. If you do, yeah. I haven't really, I've done 3 before, and it just gets really messy, so. If you think about it, it's like, it's kind of like fashion. How many different colors can you wear? You know, once you start wearing like more than one different type of clothing and it doesn't match your shoes and your shirt and your jeans or your jacket, then you're just like, ah, right on, rainbow. You know, or like, I have no idea what you're going for, avant-garde. Or even color. You know, when you think about, or not color, but or like ingredients too. You know, foods that have too many different ingredients starts to taste really muddy. So you can think about joints in that fashion. It's really a composition of what you're utilizing and how much you're going to utilize one joint over the other. Same thing with color. How much you're going to utilize one color over the other. You know, if you look at really great paintings, they're predominantly one color, right? With a complement of another color. But if you see paintings that have like 3, 4 different colors, it starts looking very garish. You know, so it's just like it's having a nice balance. Does that answer your question?
Yeah.
Okay.
Kind of curious what would it look like if you had every joint different.
I think yeah, it would look cool, but it would kind of defeat the purpose of like, why would you use a hinge joint here when you can have ball joints everywhere, you know? So it's like you would kind of run into that. but I'm sure it would look kind of interesting. I'd like to see that.
It's not an exercise.
You should do it, Rao.
Nah. Did the last term guys do this assignment too?
Nope.
No, right?
No.
I didn't think so.
Yeah, this is the first time I'm assigning this, so you guys are obviously the guinea pigs on if this is going to be successful or not.
It's a good one.
Hope it is. I saw this I can't take credit for this. This is something that I saw in one of Feng's videos, Feng Zhu.
Yeah.
He's a really great instructor. I thought it was just a really clever way of taking something that's existing and breaking it down to its core basic elements. Because we can all relate to what a bug looks like, but structurally, if we break it down into very primitive shapes, you start to get a better, very basic understanding of, okay, what to do with these pieces. You know?
That was in one of the Norman videos.
I think it,
It's on his website.
yeah, it might have been.
Where's Folio 2 DVD? I watched it like last week.
All right.
We kind of did this for VisCom 1.
I did.
You guys did this for VisCom 1 as well?
Kind of. It was like form language exploration.
Uh-huh.
Like we had to take reference and then we had to extract the fundamental design language of those references into basic shapes.
Oh, okay. That's pretty cool. Yeah, I mean, I do a lot of this stuff. Let's say if we were to take, basic human structure. Torso, hip, legs, shoulder, arms, head. Obviously, the arms also have pivot points, but just as a basic mannequin-looking thing. For the head, if it's being represented as a shape or a block, we naturally know the movements of a head, right? It can bend down and it can turn. Okay? So what bends and what turns? So bending is like, okay, this has this kind of locomotion. So it's like, oh yeah, we can substitute that with a hinge. But what allows it to turn? Oh, maybe some kind of rotating joint or something. So the first thing that comes to my mind is a rotating and hinge joint. So I'm going to combine those two for the shape of the head onto the body. That's the only thing that makes sense to me. So I'm going to add the idea of a hinge connecting to a rotating joint to the upper torso of the body. Does that make sense? Because now the head can turn up and down, and it can also turn side to side. So that's the way I would problem solve how the joints would work on a human head connected to the body. And then I would go so on, like the arms. The arms obviously have, some kind of rotating ability, or it's like a rotating cuff. So I would think, okay, a ball joint makes sense, right? So a ball joint is probably the easiest solution to cover the basic movement of an arm. And the elbow also can pivot, but it can't pivot the other way. It can only pivot up and down. So you're not going to put a ball joint for your arm. You're only going to put a hinge joint for the arm. Does that make sense? So that's kind of how I look at it. So a lot of times you'll see a mech with a very static way of standing. And it really kills your design, because no matter how awesome your inspiration was, or no matter how well it's drawn, when you have a mech that's standing like this, and it's very straight and it's very stiff, it looks very boring. You know, it's like someone, you know, just doing this, right? But when you have a little bit more attitude and more gesture, where like, you know, you don't have a guy just doing this, but you have a guy kind of leaning, you know, legs, you know, more dynamic. There's a certain amount of weight. There's a certain gesture and movement, right? We want to try to incorporate that into our mechs in some way. So the question is, how do we start doing that? I showed you guys this the first time we met, and I want you guys to do your own spread of these gestures. I just call them, they're just called stances. There's no real legitimate term for these. But I stumbled upon this idea of doing these stances by just simply just drawing a box to represent the body of the mech. Okay, it can just be a box. Keep it very simple. You should be able to burn through these fairly quickly, just like how we did the vocabulary terms for our mechs. So I'm going to draw a set of boxes here. What I want to do, what I want to push you guys to do is to really explore the different ways you can actually manipulate and bend the forms of how your mech would stand.
Does the feet need to be parallel? No.
No, they don't need parallel. They can be like, exactly. So at first, you're going to think, oh, do they need to be, you know, conservative, or, you know, you can start going really wild with them where they don't have to be all
Matching.
on the bottom. You can start changing the positioning of where the legs are going to start from, and, you know, they can flare out. Okay.
Oh, but do they need to be one parallel to each other, or like can the stance be like?
Yeah, I want you to keep them relatively parallel to each
Oh,
other.
right.
Yeah, since for these bipedal ones.
Yeah, I get.
Yeah, otherwise it's going to look like kind of awkward. But just to understand exactly where the legs are going to stem from structurally, like, you know, I want you guys to explore that. You know, what if the legs started from the front and went all the way to the back behind this, bent out, and it flared out like this? Does this concept make sense to you guys? Okay. So let's try doing 2 pages of these. I think you'll find yourself going through a page fairly quickly, and you'll find a lot of repeats. And I want you guys to keep all of these bipedal. Okay, it's very easy. For our next design, we're going to do quadruped or of your choice, and you'll do a set of variations for these, and it'll get a lot more intricate. But for this assignment, for this project, let's just keep it 2-legged only. And I want you to play with the placement of where the legs can stem and how you can manipulate the structure. You'll see how this really changes just the stance and how the mech is perceived. You know, it's still bipedal. This is the same as that concept. But why is this a lot more dynamic and a lot more appealing? It's just because of placement, right? So this is going to help sell stance. It's going to help sell a certain structure.
But isn't this, it seems that this is kind of like a leg study exercise.
This is a totally leg study exercise. This should help with your silhouettes. Because right now your silhouettes, the way we read them is side view, and it's just some crazy shape, right? But you don't know how, dimensionally, how that's going to work in space, right? So if I have something like this, and I draw it out in perspective, or in this kind of 3/4 angle view, I can have it where it's going to do something like this. You see what I mean? So think about these legs as sculpting or manipulating a wire. Okay, have you guys played with what is that? What is that called? Like that wire that we used in the kit bashing class? Well, it's called armature wire. Have you guys heard of armature wire? It's stuff that they use when they do a lot of sculpting. The reason why they use armature wire is to get a structural gesture like down before they commit to the final sculpt. So just like this, we want to find and explore what is a cool structural stance for our mech before we continue to do an awesome drawing or dress it up with all these cool aesthetic forms and put in all our details, because that's all icing on the cake, man. So structurally it has to make sense to you, it has to be cool, and you have to be content with it at the end of the day, because if you don't like the way it stands or the way the legs are, how they're positioned, you're not going to like it even if you paint it, even if it's well lit, if it's like even modeled. If the mech doesn't look good to the end of the product, it's because it failed on a very basic, primitive note. So let's do this basic study here. Draw a box.
Pages off the camera.
Oh, sorry, thanks. Draw a box. I'm going to reference this little loose sketch. So structurally, I have this box shape. The legs are going to pivot out. It's going to stem from the top backside. Legs come down and do something like this. Okay. After you get used to, drawing your insect study pages, these should be fairly easy for you guys to do. But I want you guys to do your insect drawing, gear drawings first before committing to these. Because then once you're going to start translating your own ideas and these drawings, you start to understand how to manage where to put gears. It's all about placement at this point. So for me, I'm going to start thinking about, obviously this structure is going to stem out here, but how is this, which gear am I going to put in here that's going to be the best representation? This is exactly how I plot out all my mech drawings. I start off very simple with these forms. I try to get a good idea of what I'm dealing with in terms of just mechanism before I commit to dressing up my robot.
So your initial thought is hinges and how they would work?
Yep, it's about structure. It's just like drawing a character. I gotta make sure my anatomy's good and my stance is good, Because if you have a good understanding of how to pose your character's naturally gonna look good, regardless of how crappy the costume design may be. But it's gonna be a good looking character, right? The design of the costume might not be good, but you're selling the idea with a good drawing, a good understanding of structure. So here, we're trying to establish a good structure and sense of where the mechanisms are going to be located. Maybe this is where I have like some interesting design of this feet that hinges and takes a certain amount of pressure. Again, this is just a box. You just follow my guidelines here. You can just ghost in structurally where this other leg would fall. But you notice how when I have something like this, when we think back at how simple and basic this is, and when you start dressing it up, you're like, okay, I like where this is going. This is kind of, it's fitting exactly, you know, the structure that I want for my mech. Later on, we're going to start doing just mech designs where you can start plotting the cockpit and, you know, your functional arms and pieces and bits. Do you start to see how everything is building up to the point where we want to get? So again, let's keep it basic, let's keep it at a box, but at a certain point we'll be able to tie everything in. Okay?